7, lesson 17, group collaboration. I got to get there. Okay. All right. Do you guys get everything? Part 1. Does it all make sense?
Yes. Did you get number 4? Did you get that one?
If no prior estimate for the population proportion P is available, what is the sample size formula to get the needed sample based on desired margin of error?
That's the one that's got to be Z over 2m squared.
Yeah. Right. So.
And that 2m comes from, that's 95%. And so it's 2 standard deviations away from.
Yeah. 2 of the margin of error. Yeah, good. Perfect. Okay, so part 2. It says confidence interval. In an October 2008 poll, 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. So A says find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So Carrie, Carrie or Chris, what formula would we use on that to find the proportion?
It's the 684 over 1,006.
Yeah. So P hat is equal to X over N.
So P hat is equal to 0.678.
Okay. Yeah. And then they gave us the answer. They rounded it to 2 decimal places, so 0.68. Oh. But it doesn't matter, to be honest. I mean, because we'll get instructions on how to round it when we get in there. B, check requirements in constructing a confidence interval for this data. So that's
1,006 times 67.
You say that again. I'm sorry. Hey, Lacey, will you shut the door for me, please? Thanks, sweetie.
1,006 times 0.67.
Yeah, 68. Do 68 because we'll round it up to 0.68. That's what they had us use. Yeah, and when you times those together, you've got 684 is equal or greater than or equal to 10, which it is. And then you have to do 1,006 times 1 minus 0.68 is greater to or equal to the 10.
Well, I did the 0.678 and I got 323, which is greater than 10. So I'm sure your numbers are going to be a little different than mine.
Yeah, it just barely. It's like 321.92, but both of those are greater than 10, and so the requirements are satisfied. It's considered normal. All right. So question C: determine the margin of error for a 95% confidence interval based on this data.
Okay, so that one is the one where you have to take the 6.78 or 6.7. I use 0.6799.
Yeah.
Plus or minus 1.96 because it's 95% times the square root of 6.799 times 1 minus 6.799 over 1006.
Yeah.
You're dang many numbers.
Yeah, you're saying 6.799. I think you have it right. I mean, it's 0.6799.
Oh yeah. Sorry.
I figured you had it.
That's okay. Correct. I often hit 0 instead of point anyway.
Right.
Then I look at it and go, no, that can't be right.
Right. So when we do those numbers, our margin of error becomes plus or minus 0.0288.
Okay, got that one.
Okay. Are you with us, Chris? You got it?
Yeah, I got it.
Okay. How about you, Carrie?
I'm listening. I'm actually writing up our thing so I can submit it.
Oh, okay.
Sorry. I'm listening. Sorry.
Okay. No, you're fine. And I want to go through this fast so we can talk about it because I had some thoughts on it as I was thinking about it.
Oh, should I
So.
stop writing?
Maybe.
Okay.
Maybe. Okay. D, construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years. So that's where we use the formula p hat plus or minus z times the square root of p hat 1 minus p hat over n, which we actually just for this we just found out if you just it's also the standard deviation, just that big square root of.
Yeah, so I just did the top divided by 0.2 or 0.0288.
Yeah. So 0.68 plus 0.0288 and 0.68 minus 0.0288.
Okay, so well, I used 0.6799 again, so I come out with 0.7087 and 0.6511.
Yep. That's it. So the 0.6511 is our lower bound and the 0.7087 is our upper bound. And then they wanted us to make a statement, which is we are 95% confident that the true population mean P is between 0.6511 and 0.7087. Okay. And then E, it says, how many college students should you survey if you want a 95% confidence interval with a margin of error of no more than 0.015? And this is where we have to figure out
The N.
Yeah, the N. And so I was a little bit like, so which one do we pick? But
see, what you have is you have
Hey guys.
you don't
Hey,
have
Eduardo.
any prior things, and so the only thing that you have is a 0.015,
yeah.
and so you have to 2 times that number.
Yeah, exactly. We don't have what it's called the prior estimate for population. So we don't have a P, just like Chris said. So it'd be that formula N equals the Z score divided by 2M squared.
Right.
And
Mm-hmm.
so
Your favorite.
exactly. It's because it's a 95% confidence interval. We know it's 1.96 divided by 2 times 0.015, and then remember the square because I always forget the square. And we come up with N would need to be 4,269.
Right.
Yeah. All right, question 8. So Eduardo, we're just going over part 2 of the preparation assignment.
Okay.
And then, so the hypothesis test, now you're interested in testing a claim that over 60% of all students have been in a car accident with the last 5 years. Use the same information as above and use a level of significance of 0.05. So that's where they give us P is 0.60. So they want us to state the null and alternative hypothesis.
Okay, so the null of the probability of P is equal to 0.60.
Yep.
But that
And
means
then
that the null of the alternative of P has got to be greater than 0.60.
Yeah, exactly. Because they claim that over 60% of all students have had. So they want to know greater. So then they want us to compute the test statistic. And this one is, so whenever we get to the hypothesis test, they want us to use that Excel. I'm going to share that on the screen.
Oh, they want us to use that one on this one?
Yeah, because when I
man,
computed
I figured out the long way. Dang
well,
it.
what answer did you get? Chris?
5.172, 173.
Well, you got it right. I don't know why. I think because I didn't drag out all the 0.6. But if you just do this Excel thing that they showed us, and you go type in X is 684. Like they, let me do that again. 680. Can you guys see that?
Okay, 684, 106.
Yeah, and then they wanted
95.
it.
Oh, and it's got to be a
90.
0.6.
Yeah, 0.6 is our null, and they want to know right here whether it's greater than. Then you look down at the z-score right here, and it's 5.174. And then it says with the p-value just right next to the z-score is 0.000. And that's for C. And then D asks, so if its p-value is 0.000, what decision do we make about the null hypothesis?
Reject it.
Yeah, we reject the null. And then state your conclusion, which would be something like there's sufficient evidence to conclude that the true proportion of students have been in a car accident in the last 5 years is greater than 0.6 or 60%, 0.60. All right, that was it. So let's go into our quizzes. Okay, answer question 1 and 2. All right. Question number 3. The symbol for true population proportion is which of the following?
It's the p-hat, right?
I think it's P.
I think it's just P because this.
P-hat is the sample.
Yeah. So it's kind of Carrie, it's kind of like that new versus the X with the bar on top. The new is the true population mean, and then the X with the bar was the sample mean. So this is kind of the same thing. So I would guess with P as well. Okay, for the next 2 questions, suppose that N is 100, P is 0.25, and P hat is I think that's what the guy called it on the video, so I'm like, that works. Okay, P hat is 0.10.
You do not want to know what those what comes to mind every time you say p-hat.
Right. I want to ask.
Yeah, I know. You're looking at it like, oh yeah, we put hats in the toilet all the time.
Yeah, that's right. All right, the requirements for constructing a confidence interval are satisfied. Okay, so what do we need to do to make sure they're satisfied?
Well, the first thing you have to do is N times 0.25.
Okay.
And then you have to do N times 0.75 because it's 1 minus 0.25.
Yeah. So just those formulas to figure out the requirements.
So they are satisfied.
Okay. And then, okay. Yes, Carrie.
No, I'm good.
Really?
Yeah.
You kind of had a sigh there, so I was like,
No,
all
I
right.
was no, sorry.
Okay. No, you're fine.
Sorry.
Okay. So answer 4 is true.
Well, I mean, so we know it's satisfied because we have all the data, right? I was thinking a different angle than.
This is, well, what they said is, so the requirements for a confidence interval is they have to be a simple random sample. Well, simple random, or is it, I can't remember for constructing a confidence interval, if it just has to meet the sample proportion has to meet the central limit theorem, which for proportions is N times P has to be greater than or equal to 10, and N and n times 1 minus p has to be greater than or equal to 10. So that's what the requirements are. And then for a I think for the hypothesis test, it has to be a simple random sample. Those same requirements for the confidence interval, the n times p.
Gotcha.
Okay,
So-
so. is
Yeah,
five-
both of them are the same. What
they're
was
both
that?
the same?
Say that one more time. Sorry, Chris.
Okay, so 5 is the same?
Yes,
They're both
I would
the same
agree.
to get
Five
a
is also true,
hypothesis
right?
and a confidence interval?
Yeah. They are. They're the same. I just went and looked at my notes, and
Okay.
they were the same. Okay. Question 6. A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 defendants were found guilty. So X equals 45, N equals 60. Okay. And then it wants us to find the funny p hat.
So we just put x over n, or
Correct.
solve for x,
Yeah.
right?
Yeah.
It's 45 over 60 then.
Yes.
That's
45 divided by 60, which p hat comes to
0.75.
Yep. Okay, but it says round to 3 decimals, put 0.750. Why it says that, I'm not sure, because that doesn't make sense, but that's okay. Well, okay. Yeah, I went just double checked. 0.750. Okay. Okay, create a 95% confidence interval for the true proportion of the first-degree murder trials in the state where the verdict is guilty. Input your answers for the margin of error and upper bound. Okay, so we have to do the margin of error.
Yay, by hand.
Yay! That's right. Woo-hoo! Okay,
So it's 0.750 plus or minus then.
yeah. Well, just find the margin of error. Just put Z. Okay, it's a 95% confidence interval. So
it's
M equals
1.96.
1.96 times.
I love that Chris has these all memorized.
No,
I know.
I've been working on this one. Too bad I can't translate it to the homework quizzes.
That's right.
Yeah, the homework quizzes I don't mind so much because I'm usually can narrow it down to 2 answers, so I get 2 chances. It's the exams that are killing me.
Yeah, I know.
Yeah. That last
Where
one.
I literally feel like, has anyone seen that cartoon that someone posted it online for the BYU, and it was like, yeah, it's a brain talking, and they're like, yeah, we studied this, we got this, and they're like, okay, what's the answer? And the brain goes, I don't know.
I don't know.
Yeah.
That was me. I was like, I don't know.
Yeah, exactly. Okay.
Sorry,
So
I'm always the
No.
distraction.
we need it. We need it. Seriously. Okay.
Oh, and we have a new TA, don't we?
Yes.
Yeah.
Woo.
His little picture was cute. I'm getting old, so I can appreciate those cute things. So, is
Wondering
there
why they're all babies, huh?
I work with a girl who's like, I'm like, oh, we could be friends, and I found out I could be her mom. I'm like, oh,
You can still be friends.
You can still be friends.
well, yeah, of course I could, but I'm like, she was born the year I graduated from high school. I'm like, this is the first time I've ever worked with someone I could be your mom.
Right.
Well, I could be all of your moms.
Her birthday's this week, and I'm like, oh yeah, all my friends are like studying for like exams, and I'm like, oh, do you want to go to the club? She goes, did you just ask me if you want to go to the club?
Uh,
I'm like, I don't know. I just, in my mind, I think I'm your age still. Sorry. But you know how we had to solve for the p hat before we can move into this next section of this answer? My question is, does it matter if we do like the margin of error before we do the lower bound and upper bound, or vice versa?
Yes, you
It's
have
the
to do
same
the margin
thing.
of error first.
Thank you.
Yeah.
I
The
didn't
After
truth
that,
is,
your upper lower bound.
The truth
So-
is, the margin of error is included in the whole confidence interval. So you're doing it, but they do want the answer for the margin of error. And so
So what do we use for the Z? Oh,
You
that's
just-
the 1.96,
That's
right?
1.96 because it's 95%.
See, Chris, we should just do our stuff together.
Test together too.
We should all just do it together.
I agree.
We're not really cheating. We're just helping.
We're just using our resources.
Yes. We're not
Okay.
copying. We're just talking it out.
Exactly.
Okay, so I got for the margin of error, we're supposed to round to 3 decimals. I got 0.1095 goes on, but it says we're supposed to round to 3, so I would get 0.110 if I'm rounding
the
it
5
to
would
3.
round that 9 up to a 10.
Right. Did everybody else get that?
So wouldn't it then be 110? Is that what you said? Sorry.
I got, yeah, that's what I
0.110.
got. 0.110.
0.110 for number 7 as the margin of error.
Yeah. I don't like that number. I hate when they tell me to round it.
And then you start
And
messing with
it's
it.
not, yeah, it's just not what I think it should be. Okay.
Why would they in the book give us the margin of error after the interval?
Well,
I think that's
the
rude.
tru- yeah,
Okay, as long as you agree
Okay.
with me.
it's rude. That's right.
Okay, so when you figured the margin of error, what did you put under the square root number?
What did I put under what?
Under the square root. Because the
0.7.
margin of error is
Yeah, I did 0.75
Parenthesis 1 minus.
times, yeah, 1 minus 0.75 divided by 60. Because they don't give us P. Like it doesn't,
But remember, sometimes the P and the P hat equal each other
they do,
in certain circumstances.
yeah.
But we're not privy to that information. That's how I feel.
I know. So I don't know, Chris. Or yeah, Chris, did you?
So then you've got
You agree with-
0.75 times 1 minus 0.75
Right.
divided by 60 and all square root. Okay.
Yeah. Then what you do is take. Oh, wait. Don't listen to what I just. Okay. So then you take 0.75 because then we want to find that confidence interval, and you minus it by 0.110, and I got 0.64.
Has to go to 3.
And then say that again.
Has
Yeah,
to go to
it says
0.640.
yeah 640 because they want to mess with their heads or something. I don't know. All right, 0.75 plus 0.110 equals 0.86. What's I don't like this.
I get 0.860, but I'm not thinking.
Yeah,
Oh.
because you have to round it up. I just I don't like when they do this to us because it makes you start to doubt. And yet there have been times when I've done it and been like, nope, it's not going to be the right answer. It's not going to be, and it was. So
And it's like, woohoo!
yeah, exactly. Okay, so for question 8, it's 0.640, and question 9, I got 0.860. Is that what you guys got?
Yes.
What was
Okay.
that? What was that
We'll see
again?
how-
860 for the overbound.
Point, yeah,
And for the
0.860.
0.6?
Lower bound was 0.640.
40. Okay.
So lower was 0.640 and upper was 0.860.
Yeah. Okay. Whew. All right. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
The
Well,
width will decrease. I wrote that one down somewhere.
yeah, it does. Trying to find. I wrote it down too because they always ask it.
They always ask in a different way. Essentially, the bigger your sample size, the smaller your
Well,
margin.
it's the smaller the margin of error, right? So then it would be the smaller.
So it decreased.
Increase the sample, you decrease the width of the interval. Increase the confidence level, the increase of the margin of error, and you increase the width.
Mm-hmm.
So it's decrease A, right?
Yes.
Are we ready for 11? I'll read it. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest n can be and both requirements still be met? Isn't
Okay.
that back to that formula?
Yeah, so n times 1/2, which would be 0.5. We can just say that. It has to be greater than or less than 10.
Okay, so
So let's see. 10 divided by 0.5. So, and then n times, you have to do both of them. So n times 1 minus 0.5, which still gives us 0.5, right?
Mm-hmm.
So I got 20 for both of those equations.
yes, because you had to do the 10 times the 2.
Yeah. So smallest the n could be. So Eduardo, we were talking earlier, because remember how we didn't know on last time's quiz which one of those formulas requirements that we're supposed to use.
Oh, right.
I asked the teacher, and she said it's kind of an oxymoron because it asks what is the smallest the n can be. So you do both of those formulas. The n times p is greater than or equal to 10, and n times 1 minus p, and you take the highest number because that it has to be that highest number in order for it to work. Does that make sense?
Okay. Yeah. So we're on 12, right? Now?
You got 20 for 11, right?
11, yeah.
Okay. Yeah, 12. To conduct a hypothesis test for one proportion, two requirements must be met.
10?
Suppose,
No,
yeah.
100.
So P has to be, so we
100?
do the same thing. So, equal 0.10. Let's see. Okay, so 100 is that one, and then 1 minus 0.1. So 10 divided by 0.9 would be 11.1111, right?
Yes.
Okay, so yeah, 100 would be the answer to 12.
We're on a roll, guys. We're on a roll. We got this.
We're going to do this the first time.
Heck.
Okay. Question 13. For the water quality study in the reading, about 60% of the macrovertebrate water quality indicators have historically been associated with good health. The researchers suspected that the water quality area has decreased. They conduct a hypothesis test using a significant level of 0.05 with the following hypothesis. P is equal to 0.6, P is less than 0.6. They collect new data, and this time n equals 80 and x equals 38. So our P would be 0.6, and then if we want to find the p hat, you just take the 38 divided by 80. So p hat is 0.475. I don't know what they're going to ask us, but I always do that. Okay, the conditions for conducting the hypothesis test are satisfied. So now we have to do that same equation. So,
So
80.
P is 0.6.
Yeah, P is 0.6, and we actually have N, so you just take 80 times 60 is 4,800. So that one meets it. And then if you did, oh, wait, I did that wrong, though. Sorry.
It's
80.
80 times 0.6.
Yeah, you're right.
So it's 480.
For the P hat?
80.
48.
Yeah. 80 times 0.6 is 48. So it's just 48, which is greater than 10. And then we have to do N. So 80 times 1 minus 0.6, which would be 0.4.
Which gives you 32, so they're both still satisfied.
Okay. Okay. So we can answer true for 13 that it is satisfied.
P.
Okay. What is P hat? It said round to 3 decimal. I
That's
got
when you got
0.475.
0.475.
Yeah.
40.825.
0.475. We got that by dividing X, which was 38, by 80. So that's what gave us our P hat. 0.475. And Chris is laughing at it again.
No, it's me.
Well,
I'm not Chris. Carrie is. They're all laughing at it.
I like
All
the
right,
one
so
he
now
had. I
Because I'm really only like mentally 10 years old.
well, it's just that
Okay,
in
so-
nursing you use that term all the time, and so it works for me.
Right.
Okay, so
All right. So now,
okay, go. Never mind. I won't.
no, go for it.
No, I was just okay. So
No.
our wrestling coach, okay, make the kids have to be in the correct body form. It's chest down, but we're dealing with lots of little kids, and so he will yell across the mat, "Pee pee down," to remind the boys to flip to their stomach. And so we have joked for like the last 2 years that we're going to get him a T-shirt that says "Pee pee down." But now I'm going to get a pee hat for.
That's right.
So take statistics, then you'll know what it means.
That's right. We're gonna get you one too. P hat.
Pee hat.
We should
Sorry,
buy one for
all
our
right.
teacher.
All right. So test statistic. You can compute it by hand, which is something. I have to. Z is P hat.
Not do this one on that on the category thing.
I did, but I'm curious to see if it works.
Okay.
Otherwise, but you could totally.
Because Stacy's all about doing it the hard way.
No, I did it once. I did it once and it was wrong, so I'm a little bit like, wait. But let me just see what happens. Sorry, because I like to waste time.
No, well, and my PP down story didn't help. Didn't help.
That's pretty funny. Okay, divided by 80. Square it. Okay. Sorry, I'm almost
I
there.
don't even remember what the formula is to do it by hand. We've been doing SPSS for so long.
Right. So it's in this one, it's actually different than what we used to do because you take P hat minus P divided by the square root, so the standard deviation, which is the square root. What was that?
Oh, yeah. It's the square root of
P minus
1 minus, or P times 1 minus P over N.
Yeah.
That's a lot of nasty formulas.
I know. 5, 4, 7, 7. Okay. So I actually got the same answer on that other. So it's negative 2.282 if they want us to round it to the
It's 3.
negative. No, it just stays 282.
So that's the
If they
test
want-
statistic.
Yeah, that's
Yeah, if
the
they
Z
want it-
score.
It's negative
Okay.
2.228.
It's negative 2.282.
Oh, 82. Oh, my bad.
Yeah.
Negative 2.282.
Yes.
Okay, sorry.
Nope, you're good. And then if you go to the normal probability app and plug that in, and they wanted to know if it was less than.
That's
Negative.
my favorite.
That's right. So they give us the p-value at 0.0112. They'll probably want us to round it to 3 decimals, so 0.00. I'm sorry, 0.011.
1 here.
0.011.
Wait a minute. 0.01. Oh, because you were rounding around.
Yeah.
0.11.
0.011.
0.01. Sorry.
You're fine. And then it says our level of significance is 0.05. So what do we do? Reject or fail to reject?
We fail to reject.
I thought we rejected it just because 0.011 is less than 0.05.
Is less than.
We failed to reject or reject?
Wait a minute.
No, we reject it.
When I back to the normal probability app, we plugged in a negative 2.282, right?
Negative 2.282, and then highlight to the left side only because they want to know if it's less than.
My highlighting, I had a tail highlighted. Sorry.
No, you're fine. Yeah, just highlight less than. And then 18, it said which of the following. So are we in agreement that it's to reject the null?
I agree.
Yes, because if it's small, you reject it.
Okay. Okay.
Right?
And then, yep.
Less than, you reject.
Yes, agreed. Okay. And then it says which of the following best summarizes the conclusion of this test? There is insufficient evidence to conclude that water quality in the area has not decreased. There's sufficient evidence to conclude that water quality in the area has not decreased. There's insufficient evidence to conclude that it has decreased, or sufficient evidence to conclude that water has decreased.
So our null is that it's equal. So, and when we're rejecting it, so that means there's
decreased, isn't it?
Yeah, because that was the question. We wanted to know if it had decreased. And
so there's got to be sufficient evidence to conclude that it has decreased because we rejected the null.
Yeah. So that would be D. All right, you guys ready to see what happens?
Let's see.
Sure.
I will turn it in.
I feel that 100 coming in.
You said you feel it, or you do?
I feel that 100%.
I do.
Yes, baby, we did it. 100%.
Yes.
Good job.
Okay, good job, girl.
We need to take a few minutes on our project.
Yeah.
Oh, what was
Hey.
question 3? Sorry.
So, what did you want to
Question
change? What did you want to talk about, Stacy?
Oh, okay. So
And did you figure out how we're all supposed to sign that paper?
no, we just turned
it says list the name, so I'm assuming that it says each group member sign below, or that you will not collect data until your project has been approved in writing. I think that's kind of stupid. But,
well, because some of this stuff is written as if
You were in the class.
yeah,
Right.
yeah. So I think
That's the problem with this whole book. It's written as if you were in the class, and so they.
Right.
Unfortunately, I think most of BYU Online is written as if you're in the class.
Well, and the thing that bothers me is because they haven't gone through the book, and so a lot of the online book is wrong. The answers are wrong, or the questions are wrong.
Yeah.
Well, that's what I was saying.
What I'm doing.
They at least give you 2 tries. The first time I tried this class, you didn't, and you were essentially on your own. So it was so frustrating. I didn't know if it was because I rounded wrong or if it was completely wrong and worked in the wrong formula.
Right. Yeah, I
I
do
think
appreciate.
Stacy should become a statistics teacher because she's rocking this.
No. You know what's funny is I think it was Henry B. Eyring's dad, who was just a phenomenal scientist,
Right.
who said something to the effect of, I think God looks down at us and our discoveries and laughs at us in something like at our childlike attempts to understand his world. Well, that's how I feel with statistics. I do get some of it, but I feel like for the right reasons. And so,
right side, when you create your own world, it'll all be brought to your memory, and you can use your statistics to plan your own world.
there we go. There we go. So I'm sure instructors, if I were to try to explain what I understand, they would probably giggle and laugh and say, okay, that's kind of funny, but it's all good. Okay, so here's my question. When we talked about this Skittles, we talked about trying to see. We first kind of talked about making it an ANOVA test, which is a quantitative test. But as I've been thinking about it, that would be more like taking each bag and us counting how many Skittles are actually in the bag.
Right.
And not.
Right.
But if we're going to do it by color, then we need to make it either a categorical test of one proportion. And I'll tell you why. Because we want to know, I think it's one proportion, but because we want to know how many, we were talking about knowing, are the colors the same, right? Is that right?
Right.
So I was looking up online and I came into this thing about the Skittles. I looked it up and it said when the Skittles manufacturers create bags, they take the same amount. So 20, there's 5 colors, and they take the same amount, 20% of each color equally into the mix and mix it up and then put them in the bags. So they're saying there should be an equal amount of colors technically in each bag. So that could actually be our hypothesis. Our null hypothesis is that each color should be 20%.
Represent 20%.
Right. And then we would go and count the bags and we'll find that it's not. And
or
so,
we could just do total number of pieces.
Yeah, we can do
which would be a little bit easier, but
yeah.
Well, if you do it with the colors in the bag, you can do the pie chart.
Right. That's what I'm saying. We get to do the pie chart. We get to do.
okay.
It's actually simpler in my mind than doing an ANOVA test.
Okay.
Because I was thinking about it for each state. There's just one manufacturer. Well, I don't know how many manufacturers there are of Skittles, but there's just one population, and then they send them out to different states. So I think it's easier to just say, let's go for the color.
So
test.
our null would be each color represents 20%.
20%.
Yeah.
And then your
and then,
alternative would just be that it would be not equal to. You wouldn't have to give.
We don't even have to be
less.
greater or less.
Yeah. So that's what I was kind of thinking. I don't know.
All right.
What do you guys think?
Well,
it doesn't have to.
But then we don't even have to base it on area. We'll just each of us grab a bag of the same size.
We have to decide what size bag we want. I was trying to look up what size bags there are. I think like a little personal bag is 2 ounces. There's
small.
I thought it was like 16, but
Yeah, it might be. There's
maybe
14 ounces. I think 14 ounces, the ones that cost about like $2.50.
Like what's the size you find like at the checkout counter? Not the share a bag, which I'm not going to share. And
the personal bags are 2 ounces. They're tiny. They're small. So I was thinking
small.
I was thinking either doing the 14 or the 41 ounce. The 41's like $5 or something like that. So it would.
Let's do the 14 because I think that's the size that you find at the cash register, right?
That's about a 14 ounce.
Yeah, let's do the 14 ounce. That way we have a decent number to work with.
We just have to have greater than 30.
Yeah.
And there's more than 30 in there.
That was my.
I don't want to count all those numbers, all those Skittles.
5,000 million.
Yeah.
Let's get that big bag from Costco,
No.
Hey, but our margin of error would be very small. See?
But on
No,
the flip side, we don't only have to get one bag.
that's right.
And
Okay.
Stacy has the most kids, so I bet her kids would be very helpful.
Yeah, they'd be totally cool. We'll play Don't Eat Pete or something like that with it. Okay, so it says state your research question, make it a plain English sentence, something like, we're trying to determine if the average fruit fly. So, so our research
No.
question could
Could
be
you make it as we're trying to determine if there
if there are equal amounts.
equal amounts of the color, or
Yeah.
if each color is equal to 20% of the bag?
I wouldn't say 20% because it's just our question. So I would say we're trying to determine if each color is represented equally in each bag or something like that.
Okay. Is
For you,
each is each color equally
yeah,
Equally represented in each bag?
or something like that. Don't quote my English because I'm
in a
horrible at
14
English.
ounce bag?
Well, you could just say bag of Skittles, or you could say
But I
14
think you should
ounce.
do your test as you collect your data. Then you would say a 14-ounce bag and
Okay.
Yeah.
And what's our population? Skittles?
Yeah.
population would be all Skittles.
All Skittles bags. It'd be Skittle, yeah. Yeah, exactly. And then what is your experimental unit? In other words, what is the smallest entity from which you are collecting a single piece of data to be used for analysis? And I think that's where we write 14
That's where your
ounce Skittles
14
bag.
ounce would be.
And
Okay.
then 4 says, what is our response variable? And which is a variable about which a research is asking a specific question. So that's what I'm trying to figure out. Our response variable.
Is that where you'd use the 0.20, the 20%?
Yeah. Well, it says, so I looked it up. I'm like, okay, response variable. I was trying to think of that definition. It just said it's the variable about which a researcher is asking a specific question. So yeah.
Well, the only variable you've got right now is 20%.
Yeah. So are each color, is there 20% of all 5 colors, or how do I phrase that? Do all 5 colors have 20%? I don't know. You guys figure out how to word it.
Okay. I said, does each color equal 20% of the total amount?
There you go.
Yeah.
Perfect. And
Okay,
then
and is our response variable quantitative or categorical? It's quantitative, right? Because
it's actually going to be categorical.
It's categorical.
We want to put it in categories and colors. We're actually asking about the colors.
okay, we're sorting colors.
Yeah.
Right.
Yeah.
Okay.
Even though.
Which statistical method are you going to use for your study? It should be one of the following 8 methods: quantitative, 1 sample; quantitative, 1 sample; sigma, unknown or known; 2 samples paired; quantitative, 2 samples independent; quantitative, 3 or more samples; categorical, test of 1 proportion;
That one.
of 1 proportion. Because we're only dealing with Skittles.
Yeah. Now my question is, so here's my question, and she may help us on this. In fact, you could even turn it in, and if there's a place to write notes, say we're a little uncertain about it because.
But then you say does each color, so that would.
Right. So I'm almost thinking that there's more than 1 proportion. But we don't know because we haven't done 2 proportions and chi-squared test. So we could ask her, and maybe she has a better response of how we could do this, where we actually specify, okay, is red represented 20%, or I don't know. So that's something you might want to ask her, to say we were having a hard time thinking, I don't know, because she'll go through and approve it. If there's something wrong, I'm sure she'll say that statistic method doesn't work for what you're trying to do, and we could say,
Right.
oh, okay. So
okay, so
As of now, I was picking categorical test of one proportion, but
But then you'd have to specify that you're only going to get blue or red.
right, that's what I was thinking. So that's what to ask her. Does the chi-square test, is that more like an ANOVA where you have 3 or more samples? So that's what I would want to ask. Maybe
Okay,
I'll go look at the.
So then our null hypothesis is each color is represented in the bag at 20%.
Well, but you'd have to say the HO,
Right,
null hypothesis equals
20%.
Yeah, and that's where I'm asking. That's. Blah, 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 blah. We could specify it to one color if we wanted to, or we could just ask her. We wanted to test each color. I'm going to go look down for.
Our null is HA, right?
right. No, the null is HO.
No.
Oh, I'm sorry, our
The alternative is HA.
HA. Okay, and then we're just gonna say is not equal to 20%.
Yeah.
But if you're going to do it categorically, you have to put HO of P.
Yeah, HO.
Because then you're dealing with probabilities.
Yeah, P is equal to 0.2.
So it depends on if we're going to do it categorically or if we're going to do it numerically.
Yeah. Just, Carrie, maybe if there's some notes you can ask her. Say we initially wanted to do it for all 5 colors, but realized that may not work. So should we just select one color and test it? And she may say, no, it works, and here's how. Or she may say, yeah, you're right, anyway.
She's really good about answering.
Yeah, she does. She's
okay, so number 8 says, which sampling method will your group use? Symptomatic sample, cluster sample, etc. Please review the different data collection methods. Please note that true random samples can be difficult and another method may be easier to obtain. If you do choose random sample, please describe in detail how you will ensure that experimental units are selected randomly. Note, haphazard data collection is not the same as random. This requires a lot of thought. Each team member is going to go to the store and buy a bag of Skittles.
From a different state.
Well, 2 of us are in the same state, but
oh, that's true.
Just say
but we're all different cities. We're all different cities.
Say a different area, you've got them all covered.
Yeah, there you go. Each team member will buy.
But they're going to want to know: is it cluster? Is it?
It's a simple random sample. Let's see.
But a simple random sample, you have to have, because are the team members part of the random sample? They're collecting the data, but the data is the Skittle bags.
Right. Well, so it would be the distribution. Are they being distributed from the same place? And we're grabbing a random sample.
Well, then number 9 says, describe in specific detail how your group will collect. Well, each of us are going to drive to the store. Also, what sample size are you planning? Oh, that's where it's the 14-ounce bag.
Right.
Yeah, which might be, I don't know what the sample size is in each bag, like 500. I can't remember how many Skittles are in a bag that size.
I don't like Skittles, so I've never checked.
What? Okay. Please review the requirements in the text for your chosen method from step 6 and discuss why your study is in alignment with the requirements. Step 6 was
it
categorical test one proportion.
Yeah, it should be. I mean, if we have.
Well, then you'd have to say n times p equals is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10.
Right. So
that's how you can prove it.
Okay, so we're not
Okay.
doing human subjects and we're not conducting a survey. We can go straight to 19.
Yeah, which is where we swear our lives off. Okay. How many Skittles are in a 14-ounce bag? See,
Now, what if that is variable?
it says there can be between 210 and 280 Skittles. Although,
So we have a good chance
No.
to have some variety in our data.
yeah, 210
yeah.
to 240 Skittles. 210 to 240.
So there's your margin of error then.
Yeah. Okay. So what we would do then is take 240 times 0.20, and is that going to be equal or greater than or equal to 10? And I can't
Did you
find the
just-
calculator.
Mm.
I'm just saying, as a requirements, if we're doing the right test.
Well, okay, so
Oops.
back to please review the requirements in the text for your chosen method from step 6 and discuss why your study is in alignment with the requirements.
Yeah, we meet the requirements. If we pick the right test, it would be n times p is greater than or equal to 10, which the 0.2 would be p.
There's 120.
Yeah, 240 times
No, it'd be 48.
48, and then if you do 240 times 0.8, which is the other test, it would be 192. So we meet the requirements for greater than 10 on both. And it's a simple random sample.
So for 10, I should put that our sample is greater than 10? Our sample size?
No, you'd have to put our sample satisfies the n times
Yeah,
p
say-
greater than or equal to 10. And the n times p minus 1 is greater than or equal to 10.
Okay, tell me one more time. Sample size will what?
Will satisfy the requirements of n times p is equal to greater than or equal to 10, and n times p minus 1 is greater than or equal to 10. Well, yeah, that's what tells you that you have a good sample on a categorical.
Yeah.
All right. So I'm going to scan
And then-
this and email it to her. Do we or submit it on